All right, what do I know? I know the y-intercept is negative 2/3 and the x-intercept doesn't happen, so negative 2/3. Y-intercept is negative 2/3. 0, negative 2/3. It's discontinuous, has vertical asymptotes at x equals negative 3 and x equals 1. X equals 1. Come on, pen. I want you to be visible on the video. X equals 1 and x equals negative 3. There is a horizontal asymptote at y equals 2. Other points I do know is that the graph actually goes through the asymptote here at 2, 2. Okay, that will help me figure out what's going on here. It needs to look something like this. So it's up here and here, it's here and here and here, but it's got to cross through that asymptote. Then what's it going to do? It's not allowed to cross this axis, it doesn't go that far down, and it's got to finish up over here, near that asymptote. So it's actually going to finish underneath. And I know the graph doesn't cross the horizontal asymptote anywhere else because I actually solved it and there's only one place where it crosses. So the only possible way that this can draw is like this, which actually means there's going to be a maximum point here somewhere, but it doesn't cross the x-axis. So this one's going to come up to here and then go down again through there, down. This one's going to come down through here. What I don't know is how far down it goes, and then it's going to come back up again towards the asymptote. I just know it doesn't get to here. This one's going to come down here and across here. I don't know where they meet. This is the sort of situation where you plug in a couple of extra values, let's say -5 and 5, and work it out. The other thing you can do is go back to that S in ideas. You could actually differentiate the function to work out the coordinates of the stationary points. There's one here and there's one here. Now, I'm going to leave that as a separate extra extension because you don't really need it just to get an idea of what the graph does. I'm just going to do the simple version now. I'm going to substitute in -5 and +5 and see what happens. So, at x equals -5, y is 2 times 25 plus 2 over 25 minus 10 minus 3. Well, that's 52 over 15 over 12. So 48 on 12 would be 4. So this is 4 and 4. Maybe I should be simplifying this first. 48 on 12 would be 4, and I've got 4 left over. 4/12, which is 4 and 1/3. And at x equals +5, y is the same, a lot of it's the same, 2 times 25 plus 2 over 25 plus 10 minus 3. That's 52 over 35 minus 3 is 32. 32 would be 64. It's just less than 2. Can I get it better than that? 26 on 16, which is 13 on 8, which is 1 5/8. Okay, back to the graph. Put those 2 points on. It's going to go through -5 and 4 1/3. And it's going to go through 5 and 1 5/8. So it's actually still very, very close to 2. It doesn't even come this low. This point is 5 and 1 5/8. So my graph doesn't come down very far at all. It gets very, very close to that asymptote. And this one comes down through that point and across to there. And this is 2x squared plus 2 over x squared plus 2x minus 3.